these are the values or these are the matrix how image will be look in matrix. For us it is like that, but in the background it is matrix by row and column. This is image of 512 by 512. So it will represent elements 512 cross 512. That means more than 63,000 values are there to represent our image, a single image. Next, if we want to find out the size as have seen in that, so there are two parameters row comma column, and size is matrix inbuilt function which gives size of your image. Now again run with this code and it will give size of an image. You can see in workspace. Further we have added only OI, so it will give only OI values. Now we have added two variables row and column for the size of the watermark. So R represent row and C represent column numbers in that load watermark. Now the image matrix in row and column. This is window where you can see the values of minimum and maximum. Row number minimum is 512 and column is also 512. So it will represent R equal to 512 and C equal to 512. One program I have made for image watermarking. I can show you that program, so you can find out the idea how watermark will be done. This is original image. This is watermark little angel. It is added to this image, and after that you can find out the watermark image like that. You can't find out the watermark which is inserted into that. The hiding image little angel into the image Hunner, but you can't specify this image has watermark or any secret key. When someone is downloaded this image from the internet, they can find out the watermark as it is invisible, but after attack, might be chances to extract the watermark. So robustness is necessary in any watermarking system. This is code for that watermarking scheme. First of all, load the original image, then after load the watermark image. In that I have used for wavelet transform domain, so it decompose the image into 4 parts. Again for second level decomposition, it will divide the first level of LL band in 4 parts. In that I have selected again first level of second level decomposition, means LL1 band. In LL1 band I have used singular value decomposition, which divide your matrix into 3 parts, U, S and V as given in that. U represent orthogonal matrices, V represent orthogonal matrices, and S is singular value decomposition. You can see that in workspace the value of any matrices U, V and S. You can see the matrices U will look like that. The matrices V is orthogonal matrices. So again it will decompose into 128 by 128. Our original image is 512 by 512. I have decomposed it into first level, so it becomes 256 by 256. Again decomposition is make it to 128 by 128. So our watermark should be size of 128 by 128, and you can see in that our watermark image little angel is 128 by 128. It is given in that. You can see the size of the image 128 by 128 double. Then after selection of singular value decomposition. Why selection of singular value decomposition? Singular value decomposition is technique which identify eigenvalues and eigenvectors. So you can put in your watermark into singular value which is not imperceptible to, which is perceptible to human eyes, and you can put insertion in singular value which is very crucial data and critical value which is robust against any kind of watermark. So for better result it is selection of singular value decomposition. Then after I have applied DCT coefficient into singular value matrices and create two sequence PN sequence. PN sequence is pseudo random sequence for generate random numbers sequence which gives almost binary random number sequence. I have created two sequence 0 and 1 and then taken correlation of that sequence for best uncorrelated sequences 0 and 1. I have divided singular matrix S into 4 by 4 matrix. So 128 by 128 divided by 4 by 4. So afterwards you can find out 32 by 32 matrix, and DCT block containing 4 by 4. In that DCT to apply for particular block. Identify the message vector. Message vector is reshaped watermark using any binary values. If watermark image bit is 0, then use PN sequence 0, otherwise use PN sequence 1 to add the watermark. The code for watermark is DCT block equal to DCT block plus gain factor and watermark bit as PN sequence. Then after I have taken inverse DCT for watermarking and applied to the watermark image. This process is done for all block 32 by 32, and then after containing inverse DCT of that blocks and put into one image. So you can get afterwards the image with watermark insertion and inverse DCT. Then after, as we have done singular value decomposition, so again we have to put these three matrices together. So in next I have put the three matrices together. You can see in that watermark image equal to U into watermark and then V dash. Watermark image is singular value decomposition modification values. Then after performing inverse DWT transformation for first level and for second level, and now you can get this is WI is your watermark image. As you have seen in after running the execution of program, you can't find out the watermark image is putting in the original image and it looks like that the same. Again we can see that this is your original image, this is your watermark which is inserted in this image, and this is your watermark image. So little angel image is in that image, but it is in hidden format, so you cannot find out that image, and you can protect your image by hiding data into that. After that you can select the ratio how original image and watermark image by visual system it is look like same, but as per matrix or as per mathematical calculation it is different. So how differ it is from one to each other, you can find out using PNSR function. This PNSR function value is given like that. Using PNSR, the original value and watermark value. This is the value of PNSR, 86.0552. That means the correlation between these two images is very robust. The PNSR ratio which is greater than 35 are said to be good robustness. So here we have achieved 86 point something. That means our watermarking system has too much robustness against the all kind of attacks of the watermark. Some kind of watermarks attacks like JPG compression. Further, you know that when you download image from the internet, suppose it is in BMP format, so you want to compress it, so you convert it into JPG format. After conversion of BMP to JPG, it is illegal attack, okay, but it is not intentional attack, it is unintentional attack. But also we have to consider that kind of attacks also. So our watermark should be remain present after compression from BMP to JPG conversion. When you convert BMP image into JPG compression, that means your high frequency bit will be compressed and low frequency bit remains as it is. That's why I have selected LL band for the watermark insertion. Why watermark insertion for LL band? LL band represent crucial information about the watermark original image, while LH, HL and HH band has high frequency which is degraded after compression of any JPG or etc. That's why. Again, this is normalized correlation between original image and watermark image. The value of normalized correlation is 0.9998. That means correlation between the watermark image and original image is very good and very symmetrical. You know that the correlation is lies between -1 to 1 and our value is near about to 1. 0.9998 is almost 1. So the correlation between original image and watermark image is good. Next is watermark extraction. Once we have insert watermark into the image, the next process is decoding. First process is encoding the watermark, second process is decoding the watermark, because at the time of end we want to find out the watermark, our secret key or signature. So the next process is watermarking extraction. Again select watermark image, divide into one level decomposition, divide into second level wavelet decomposition and select the LL band, because we only know the insertion of watermark into the LL band. So any hackers or attackers can't find out watermarks region as per human visual system, in which portion the watermark will be. So we know that our watermark in the LL region, so we have selected again for extraction LL region. Then after perform singular value decomposition that for that LL region. As singular value decomposition decompose the LL band into three matrices U, V and S. U stands for orthogonal, V stands for orthogonal matrices and S stands for singular value decomposition. In that select the value of watermark singular. After that find out the DCT block 4 by 4 which divides the singular value decomposition into 32 by 32 block. Then after perform DCT on particular block and find out the block size. Find out if midband coefficient value equal to 1, then prepare sequence and get the value of that midband coefficient. Then after they perform this all for all midband values and check out for the correlation 1 and correlation 2. This is for correlation sequence Pn 0 and again is correlation sequence Pn sequence 1. After correlation we check it out if correlation sequence 1 is greater than correlation sequence 0, then message vector bit is 0, otherwise 1. Based on that we can find out the watermark bits into the image and collect it into the new vector. This procedure is followed to all 32 by 32 blocks, and then after we can recollect our watermark bits using this technique. After message vector is collected, we can reshape into the 32 by 32 as our watermark is 120 by 120 by 128 image. That's why we reshape that message into 128 by 128, and then after we show the extracted watermark image like that. This is our extracted watermark. Now you can see you have inserted watermark little angel and you have find out the same watermark after extraction process. So again after extraction you can find out original image as well as your watermark image, and this is your secret key. I have selected binary image little angel, but you can select any color image or any color or grayscale image for the watermark. You can put your on signature also. Your digital signature can also be put as a image as a hide your, or you can hide it into the your document. As per result, again correlation between original watermark and extracted watermark is maintained, and it is 32.4064, and the correlation between this